Hello. Now we will discuss fault tree analysis gate by gate method. Actually, this is under the fault tree quantification. In last class, you have seen how fault tree is constructed. So, repeat this. So, what happened? You first find out the top event, then find out the first level contributors, then find out some logic gate to link with the first level contributors, and then find out the second level contributors, and then find out gate again, again you find out gate here, then maybe the fourth level contributors. Suppose here one AND gate, another contribution, and here may be OR gate and contribution. So, this top event is finally linked to bottom events. These are the component level events B1, B2, B3, B4, B5, B6, B7, B8, B9. Okay. So, when you are at the top level, we say that you use the concept called INS, find out the immediate, necessary, sufficient, that intermediate events, immediate bottom events which will cause the top events, put a particular gate, and then that gate is a logical gate. Here this logic gate is AND. So, this means these three immediate event must occur for the top event to occur. Now, here this one is maybe the subsystem level that failure event. Then you require to find out further events at the lower level, and in this process from system level event to the component level event you find out, and at the component level you use PSC concept. Okay, and this is what is known as fault tree construction. Now, once the fault tree is constructed, you require to quantify the top event. That is, what is the quantification here? Probability of top event. If top event equal to E, then what is the probability of E? So, how can you get it? You can get if PE, or you can quantify PE given the basic events. As basic events are the component level events, their data is available, or data can be obtained from reliability handbook, or data can be obtained from historical records, or at the last maybe you will go by expert opinion from subjective probability to objective probability computation you can do. So, that means what is required for fault tree quantification? In fault tree quantification, input is first is the qualitative fault tree. This qualitative fault tree links the top event to the bottom event or component level event. Then you require to know the component level probability or basic event probabilities. Basic event probabilities can be found from historical data, basic event probabilities, historical data. Number 2 can be reliability handbook. Number 3, you maybe your manufacturer will specify this one, manufacturer specification. Number 4, many cases you rely on expert opinion. So, expert opinion can be subjective in nature, it can be objectively quantified the probability. So, once you have the bottom level or basic event probabilities, then you can compute the top event, that is probability of top event, by different methods. Okay. One of the method is gate by gate method. So, in this lecture we will discuss this gate by gate method. Okay. So, another method will be Cartset method. Okay. So, that we will discuss in next lecture. So, for your reference, you follow this book, Probability Risk Assessment and Management for Engineer and Scientist. This is by Komamoto and Henle, and you can go through any of good reliability engineering handbook or safety engineering book. You will find out the quantification part, fault tree quantification. Okay. So, then what is our topic in this lecture? Fault tree quantification by gate method. So, let me repeat, the aim of fault tree quantification is to find out the probability of the top event to occur when the probability of the basic event occurrences are known. The basic event may be independent or dependent. The assumptions of independency make the mathematics simpler. Dependent basic events are result of common cause failure. The two mostly used method for quantification is gate by gate method and Cartset method. We will see both. This lecture gate by gate method followed by Cartset method. So, when we talk about gate by gate method, this is what is the issue. First is when there is AND gate, then the Venn diagram, that means probability B1 and B2, these two events, their probability PB1 and PB2 are known. Now, here the top event is E. So, what is the probability that top event will occur given that the bottom event or component event occurs? This is a very simple one. So, now this equivalent Venn diagram is this. This first circle talks about probability of B1 and second circle talk about probability of B2. What is AND gate? AND gate means both B1 and B2 should occur, then only the top event will occur. So, that means in this diagram you can see what is the common portion. This common portion, the black portion, this is the probability that both B1 and B2 occur. So, the common portion when is basically logically represented by AND gate. So, that is why probability of E equal to probability of B1 into probability of B2. This is the common portion. So, intersection, that is probability of E equal to probability of B1 intersection probability of E equal to probability of B1 intersection B2. B1 intersection B2 is this overlap portion. So, suppose this is the simplest fault tree. So, you have one top event and two basic bottom event and your calculation is like this. Now, what will happen if you have B1, B2, B3? So, if they are independent, ultimately PB1 into PB2 into PB3 like this. Suppose the second, this is what is gate by gate quantification, but in real fault tree there will be many gates. So, many you have to compute every gate. So, that is why gate by gate method. So, first basic gate operation or quantification you see. Second one is OR gate. What is OR gate? That means if any of the basic event occur, top event will occur. This is our OR gate. If any of the basic event occur, top event will occur. Now, the probability of B1 is represented by this first circle, B2 represented by the second circle. So, then if I say that both either B1, B2 or both will occur, then this overlap portion and the non-overlap portion, all portion. So, that means the probability is this portion plus this portion. That means non-overlap portion of B1, non-overlap portion of B2 plus overlap portion. So, then what is PB1? PB1 is the first circle. So, probability of E equal to probability of B1 union B2. So, this union means the total. Here what happened, this equal to probability of B1, so this portion. Now, probability of B2, again this portion. So, by adding probability of B1 and probability of B2, you are adding this overlap portion twice. What is this overlap portion? That is interjoint probability, intersection, PB1 and PB2. So, as by adding PB1 and PB2, you are adding this overlap portion twice. So, one reduction, that means subtraction is possible, required. So, that is why PB1 plus PB2 minus PB1 and PB2. So, this is basically, if it is OR gate, you will use this formula. What will happen if it is a priority? If it is a priority AND gate. So, priority AND gate means B1, B2 should occur, but the order. So, that means first B1 occur followed by B2 occur. So, the probability of E is definitely the intersection probability of B1 intersection B2 into something. What is this? That how many order possible and how many is in favor. So, as there are two input events, so either B1, B2, B1 first occur followed by B2 or B2 first occur followed by B1. So, that means it is factorial 2 ways this will occur. How many combinations are favoring this to happen? Only one. So, what is the probability of that priority ordering? 1 by factorial 2. So, that is why that PB1 into PB2 into probability of that combination, suppose C, and then that is 1 by 2. So, this is the probability. Now, what will happen if you have something more? So, what will happen? PB1 into PB2 into PB3 like this into PBk divided by factorial k, because this order is very important. So, this is priority AND gate. Similarly, exclusive OR gate. Exclusive OR gate means what happened? Either this occur, but not both. So, this is the symbol. Now, if we write probability of E, the top event, PB1 first part plus PB2 second part, then twice we have taken this to PB1, PB2. Okay. So, you either use Venn diagram or some logic, but you have to have for every gate you have to find out the gate, the output probability of the gate given the input probability. Either it is AND gate or exclusive OR gate or parity AND gate, that is what you have to do. Now, here I am showing you that how this formula is derived, this formula. You see, this is our priority AND gate. Its equivalent representation is this, that PB1 or B1, B2 should occur, but at the same time the condition is B1 exists when B2 occurs. That means B2 already or B1 occurs before B2 occurs. So, this equivalently represented by this. So, B1, B1, B2, B2 and this condition we are representing by C. So, that means it is an AND gate with 3 inputs B1, B2 and C. The C part, probability of C is this. So, that is the derivation. Now, exclusive OR gate, we have seen that PB1, probability of E, what you have seen? Probability of E, PB1 plus PB2 minus 2 PB1 PB2. What is exclusive OR gate? That either of the two should occur, but not both. So, its equivalent, this is exclusive OR gate, its equivalent OR and representation is this. So, B 1 should occur, B 2 should not occur, that is why B 2 bar. Here B 2 occur, but B 1 should not occur, that is B 1 bar. Then B 1 occur, B 2 does not occur, then this AND gate, if this condition satisfied, E will occur. Other way B 2 occur, B 1 will not occur, this condition satisfied, E will occur. So, that is why these two conditions with in terms of in the gate of G 1 and G 2 are linked with E by an OR gate. This is an OR gate. So, if G 1 condition and G 2 condition either of the two occurs, then E 1 will occur. So, its equivalent probability representation, that means this is equivalently represented by this. Now, if you want to compute the probability, then this is what is the computation. Probability of E, probability this is linked with gate G 1 and G 2 by an OR gate. So, that is why the top event probability is this immediate child event probability, that input probability G 1 plus G 2 minus their intersections, that you have seen in OR gate. Now, what is G 1? G 1 is G 1, you have seen that G 1 linked, this is basically an AND gate with B 1 and B 2 bar. So, B 1 and this side B 2 bar, B 1 should occur, B 2 should not occur. So, that is why G 1, because of AND gate, it is B 1 intersection B 2 bar. So, G 1 we can write in terms of Venn diagram B 1 intersection B 2 bar. Now, this can be written as B 1 intersection 1 minus B 2, because B 2 that event either occur or does not occur. The occurrence, if it is B 2, then one B 2 bar is 1 minus this. So, then this can be written as B 1 minus B 1 intersection B 2, B 1 intersection B 2, that is what is written here. So, as a result, what happened when you are writing P G 1, you are writing P B 1 minus probability of B 1 intersection B 2, that is what you have written here. Now, P B 1 and this intersection, as they are independent, that is P B 1 into P B 2. So, the first gate is probability is quantified. Similarly, for G 2 also, for G 2 that is also an AND gate, and you will find out that it is B 1 bar and B 2, these are the input. So, B 1 bar is 1 minus B 1 and B 2 B 2. So, when you multiply that you do similar derivation, you will get P G 2 equal to P B 2 minus probability of B 1 into probability of B 2, P B 2 is probability of B 2. Okay. So, that means these two gates G 1 and G 2 are quantified. Then what is E? E is linked with an OR gate to what? That is G 1 and G 2. So, when it is OR gate, you will see P G 1 probability of G 2 minus this. So, we have quantified P G 1 here by this method, P G 2 by this method, but the intersection is not quantified yet. So, if you write intersection G 1 intersection G 2, so you have already seen that G 1 equal to B 1 minus this. So, you write this, and intersection again you write G 2 like this. So, if you do the algebraic manipulation here, what happened? B 1 B 2, then B 1 B 1 B 2, B 1 B 1 B 1 B 2, then minus B 1 B 2 B 2 plus B 1 intersection B 2 B 1 intersection this B 2 again. So, B 1 intersection B 2 is okay. Now, B 1 B 1 B 2 is nothing but B 1 intersection B 2, then B 1 B 2 B 2 nothing but B 1 intersection B 2, and this also nothing but B 1 intersection B 2. So, that means B 1 intersection B 2 B 1 intersection B 2 cancel out, B 1 B 2 into cancel out, this is giving you 0. So, this particular part will become 0. Then P E probability of E this is Pg1 plus Pg2, Pg1 plus Pg2 with an OR gate. Okay, this one, the same formula we have written here, but this will become 0. So, then Pg1 is what? Pb1, then Pb1 into Pb2 and Pb2 like this. So, okay, this can be written like this, Pb1 minus Pb1 Pb2, this is for this part, Pg2. So, plus Pb2 minus Pb1 Pb2, then this part is 0. So, then Pb1 Pb1 Pb2 Pb2 minus Pb1 into Pb2 minus Pb1 Pb2 to Pb1 into Pb2, that is what is the derivation. So, if you go back, you see this is what is the derivation, exclusive OR gate Pb1 Pb2 minus 2 Pb1 into Pb2. Now, the last one from the last two, inhibit gate and voting gate. So, we have discussed that inhibit gate in the last class, and you have seen that it is nothing but that an AND gate, equivalent AND gate. So, that is why what happen in case of inhibit gate, the top event will occur, only both the event will occur and it is the intersection. Please remember, we are basically talking about all the cases independent basic events. Now, in case of voting gate, that you have seen that m out of n. So, if we consider 2 by 3, that 3 inputs are there, if 2 of the 3 inputs occur, then the output will occur, that is the situation. And under 2 by 3 voting case, then your derivation probability of top event or the output event will be Pb1 into Pb2 plus Pb2 Pb3 plus Pb3 Pb1 minus 2 Pb1 Pb2 and into Pb3. So, that is what is the formula. Now, we will see that how this formula is derived. Okay, I told you about this is simple one, that it is the inhibit gate and it is equivalent to this, and then probability is this. So, we have discussed this, no need of discussing further, but this one let us discuss. Okay. So, what is what we are doing here? First, this voting gate 2 by 3 gate is represented in equivalent OR and AND gate. This is AND gate, OR and AND gate. So, if 2 out of 3 occurs, top event will occur. So, then if B1 B2 occur, top event will occur, B2 B3 occur, top event will occur, or B3 B1 occur, top level will occur. So, what that is why what happened, that means this condition or this condition are in AND gate, that gate number G1, G2 and G3, and then any of these conditions occur lead to top event occur, that is why the OR gate is given here. So, the quantification gate by gate means first you quantify gate 1, second quantify gate 2, third quantify gate 3, then you quantify this gate 4. So, what is the first gate? They are AND gate. So, it is B1 and B2, and G2, that is B2 B3 and G3 B3 B1. So, G1 and then what is the E? Any one of these. So, that means the union part, G1 union G2 union G3. So, as a result, G1 is B1 intersection B2, G2 is B2 intersection B3, G3 is this. So, you do this. Okay. So, if you proceed in this manner, you see your ultimate aim is basically to find out the probability of E. Now, this is the equivalent Venn diagram, and you see that ultimately the probability from here, what is required, probability of B 1 and B 2, probability B 1 and B 2 this intersection, B 2 B 3. So, B 2 B 3 this intersection, sorry, this intersection, and B 3 B 1 B 3 B 1 this intersections. So, that means this one, this intersection and this intersection, and then minus the joint one, this one, B 1 B 2 B 3, this black one. So, that will be, because when you are taking this and this, you are basically considering 3 times the overlap portion. So, 2 times you have to subtract, and this is your formula. So, now let us see the same principle we will use to quantify a fault tree, and the fault tree that example that oven fails to burn, what we have seen in the last class qualitatively, we have developed this, and suppose the primary failures or the basic events, burner failure given, cylinder is empty is given, automatic valve malfunctioning is also given, operator mistake given, primary failure of valve is also given, tube failure is given, jamming of tube is given, ignore secondary failure of oven and valves, we are ignoring this. So, under this condition your fault tree is this. So, interesting thing is that this all the basic event probabilities you see, basic event probabilities are given. Now, what you require to do, you start gate by gate method. You cannot start here because you do not know this probability. So, you have to start from the bottom. So, it is basically bottom up. So, you find out that which are the gates that can be quantified. These two probability available, so and this is an OR gate. So, this probability can be computed. Similarly, this probability can be computed. Similarly, using these two, this probability can be computed, but this is not computed, cannot be computed because unless we know these two. So, is these two with OR gate. So, what will be the probability of D? This plus this minus this into this. What is the probability of this? This plus this minus this, probability of this into probability of this. So, if you calculate, you will get the probability of D is this, probability of F is this. Again it is another OR gate. So, that means what will be the probability of C? Probability of D plus probability of F minus probability of D into F will give you this one. Similarly, this side probability of B will be the probability of 10 to the power minus 2 plus 10 to the power minus 4 minus 10 to the power minus 2 into 10 to the power minus 4, this will give you this probability. Now, so that means now probability of B is known, probability of C is known. So, probability of A will be known, because again this is AND gate. So, this plus this minus this into this gives you this, means what is probability of A 1 for example, then it will be probability of 0 1 0 0 9 9 plus 0.020978 minus 0.100099 into 0.020978. This is nothing but this value. So, similarly, now you know this probability, you also know this gate A probability, again AND gate is, OR gate is there. So, this plus this minus this into this will give you this. So, that in this particular oven example, the probability that burner will fail to run or fail to burn is 0.0318. So, that means what we are expecting, that it at 100 times if you do if you run burn the oven, 3 times it will not burn. It is quite high in that sense, but but those probability values, basic event probabilities values are not the true values. It is basically hypothetical values I have given some probability values. Okay, so that means these probability values will be much low, so that this will also be much low. That is actually what will happen. But suppose if these are the probabilities, bottom level probability, basic event probabilities are like this is the procedure you follow. Now, leakage of gas case, see here. So, these are the basic events. Suppose this is B1, this is B2, then this one is B3, B4, B5, B6, let it be B7. So, you have data on B1, B2, B7. So, B1 to B7, this probability data, that means PB1 to PB7, this data are available with you. So, you the same manner as these are available here OR gate. So, you know how to do. Suppose this probability will be this one. Now, this probability and this probability is known, but it is an AND gate. So, this into this. So, that means 0.00910 and 20. So, 0.000975 will the probability of this. This probability is known, this probability is computed. Now, this is an AND gate. So, this into this will give you this probability. This side again this AND gate, this into this probability. So, now what happened? You have an OR gate and you have one probability, here another probability, another probability. So, probability, that means union of the probability of leakage of gas equal to probability of B1 this, union this, union this. So, then use the formula. I mean this into this plus this into this plus this into this. So, like this all the intersection minus the common part, 3 intersection and minus the common part ultimately will give you this one. So, which formula we will use here? We will use this formula, last case this formula. Okay. So, this is what is the gate by gate method. So, what we have done in gate by gate method? We started with the bottom most one, then bottommost gate is first quantified and we will go up, and finally, the topmost gate will be quantified, which will nothing but the quantification of the top level event or top event. This is known as gate by gate method. So, I hope that you understood it fully, because this is a very simple one and computation is also there very simple. And essentially what happen, whatever gates you have, you just, if it is not AND and OR gate, you transfer this or transform to equivalent AND and OR gate. So, that this Boolean algebra case you will be able to use. Otherwise, you have to use the straightaway formula, but it is difficult to remember. But AND and OR gate formula is easy to remember. Okay. Thank you very much.